Okay, let's look at the solution of this paper. Question 1. The measured length of a piece of the paper is 29.7 cm, correct to the nearest 0.1 cm. This is the finest marking unit. Okay, that means if you have a ruler, that's a 0.1, 0.2, 0.3, and so on. There's a distance between the marking. Okay, and which of the following is the possible range of the actual length of that piece of paper? Okay, first of all, you need to find the maximum error. That is the finest marking over 2. So that is 0.05 cm. And then for you to find the lower limit, that is the measured value minus the maximum error. Okay, that is 29.65 cm. And the upper limit, that is 29.7 plus the maximum error, that is 29.75 cm. So the answer would be D. D for dog. And you can see A, B, and C are not correct because A, B, C, all of the upper limits are out of the range. Okay. So question number 2. Round off this number to 3 significant figures. So when you are considering this number, which number is the first significant figure? Okay, this is the first significant figure. Okay, starting from the leftmost non-zero digit will be the first significant figure. That is the second significant figure, and the third one. Okay, the third one. That's the fourth one. Okay, so you are just considering rounding off this number to 3 significant figures. So you need to look at the fourth number here. You should round it up because it's greater than 5. So when you move 1 unit upward, they will become 10, and then move again, become 10, and then move 1 more, become 5. So you will write something like this, right? 0.005. But you need to round to 3 significant figures. As I told you, for the leftmost first non-zero number will be the first significant figure only. So you need to add 2 more 0 to make it as a 3 significant figure. Okay, so therefore the final answer will be D. D for dog. And go to question number 3. 2m squared n bracket to the power 3 over m to the power 5 times n to the power 8. So first of all, you can try to remove the bracket by multiplying this 3 inside to every one of them. What does that mean, every one? That means 3, this index should given to 2. That's become 2 to the power 3. And next, this power 3 should multiply to this power 2. So it will be m to the power 6. Finally, this power 3 should multiply to this n to the power 1. So n to the power 3 in the numerator. Okay, in the denominator, m to the power 5, n to the power 8. So after you're doing the simplification, they will become 2 to the power 3, that's 8. So A, B are not the answer. And then m to the power 6 over m to the power 5, so it's m to the power 1 here. And finally, n to the power 3 over n to the power 8. When you are doing the division with the same basis, then you are doing the subtraction of the index. So originally there should be n to the power negative 5 here, but I want to become to positive, so that is n to the power 5. More n in the denominator. Okay, more n in the denominator. So numerator all n are cancelled, and in the denominator only 5 of n left. So the answer in here, that is C. Okay. Question number 4. Consider this polynomial. Which of the following is not true? First one, coefficient of the x term is 4. This one, correct. B, constant term is 8. Not correct. Because when you are considering the polynomial 4x plus 5x squared minus 8, there are 3 terms. First term, this one, 4x. Second term, positive 5x squared. Third term, negative 8. You should get both the sign and the magnitude. Okay, the constant term should be negative 8, not 8. So B is not true. The answer is B. And then let's move to question number 5. It is given that m equals s plus 2 over t plus s, and m equals 1 over 4, t equals 2 over 28, find s. So m equals s plus 2 over t minus s, and m is 1 over 4, so you substitute in 1 over 4 equals s plus 2 over t, that is 28, 28 minus s. Okay, then what's the next step you should do? You can solve it directly, of course. And how do you start? If the numerator and denominator have more than one term, give the bracket to it. And next, you can see that both sides of the equation have only one fraction. Then you can perform cross multiplication. How does it work? You fix the numerator, don't move. Denominator, go to the opposite direction. So that's become 28 minus s equals 4 bracket s plus 2. Alright? And then multiply 4 inside the bracket. So 28 minus 8, 20. Negative s move to another side, become positive s. 4s plus s. And here 4s plus s, there's a hidden 1 here. That means 4s plus 1s. So that is 20 plus equals to 5s. And s equals to 4. So the answer would be A. Okay, if you have no problem, then move to question number 6. Use the figure below, solve the equations. This is called a simultaneous equation, okay, with 2 unknowns and 2 equations graphically. Here, that's a very important concept is, if you want to solving simultaneous equations, that is same as finding intersection of 2 lines. Exactly the same, the concept. Okay, they're equivalent. So if we want to solve these solve this system of equation, or we call it as a simultaneous equation, you find the intersecting point. Actually, it's here. So let's enlarge the size. You know this point, there's an intersecting point. So how do we read this point? Is you can starting from here. How do we move from the origin to this point? Okay, first one, we move it horizontally and then move it upward. So this point could be written as 2, 3. First of all, we move it horizontally to the right, positive 2, and then move upward 3 units, so positive 3. And therefore, the answer would be B, 2, 3. And this point 2, 3 means when you solve the simultaneous equation, x equals 2 at the same time, y equals 3. Okay? That's the solution of this simultaneous equation. X equals 2 at the same time. This symbol means and. You must have this bracket. You must have this big bracket. Okay? Some of you may write down something like this: x equals to 2, comma, y equals to 3. It's not quite good. Okay? Not quite good. This is not preferred. Okay? We prefer this one. Okay? Not so prefer this one. Alright? So that's the solution of question number 6. And let me decrease the size in a suitable scale, and go to question number 7. That's the question about ratio. So, and A to B is 5 to 9, and B to C, that is 4 to 5. You need to find A to B to C. As you can see, these two has a common letter B, and one of the number is 9 and other number is 4. You need to do is find the LCM of 4 and 9. That is 36. Okay, so what does that mean? That means you need to change this number 9 to 36. This 4 change to 36. So that's equals to, from 9 change to 36, you need to multiply by 4. So both of these numbers, you need to multiply it by 4, okay? So 20 to 36. And other one, this ratio from 4 becomes 36, you need to multiply this number by 9. Therefore, this 5, you also need to multiply by 9 also. So that is 36 to 45. And hence the answer is 20 to 36 to 45. That's the ratio of A to B to C. Therefore, the answer is C. Alright? And then move to question number 8. That's the question about the rate. A train travels 240 kilometers in 2.5 hours. How long does it take the train to travel 144 kilometers? Okay, as we know that the important formula is speed equals to distance over time. And in this case, we assume the speed of the train would not change. Therefore, distance 240 over 2.5 actually is the speed of the train. That will equals to 144 over the time t. Alright, then you can solve this equation. 240 times t equals to 144 times 2.5. That's 360. Then t, that is 1.5. But here 1.5 is in hour, so we need to change it back to minutes. The answer is C, 90 minutes. Okay, just multiply this 1.5 hour to 60. That's become 90 minutes. Alright, so move to question number 9. In the figure, A, B, C, D, E, F, G, H, B, E, and C, F, I are all straight lines. Very good. So if A equals to B, okay, these two equal, which of the following must be true? If you know that A and B are equal, that means these two must be parallel. So option 1 is true. Because these two corresponding angles equal, then you can conclude that AC is parallel to DG. And next, as you deduced from statement 1, these two straight lines are parallel. Therefore, C and D would equal, since they are alternate angles in a pair of parallel lines. So statement 2 is also true. So go to statement 3, HE parallel to CI. Do you have any information about these two? Okay, so let's see. This is 1x0 degree minus b. If you want HE parallel to CI, then what you need? What you need is 1x0 degree minus b equals d. But you do not have any information about these two numbers. So this statement 3 may not be true. Okay, so we would not choose option B, would not choose C, would not choose B, because all of these have statement 3. Okay, we cannot make sure. So the final answer is A. And go to question number 10. Simplify this algebraic expressions. X minus 4 bracket square minus bracket 2x squared plus 7x. Here, x minus 4 bracket square can be written as x minus 4 times x minus 4, and then minus 2x squared plus 7x. So you can expand this one, that is x squared minus 4x minus 4x plus 16. And here you need to multiply this negative sign inside to both terms. There's negative 2x squared minus 7x. So you will get that is x squared minus 2x squared. Then you will get negative x squared, negative 4x, minus 4x, minus 7x, in total minus 15x. Finally, there's only one constant term, plus 16. So the answer is B, B for boy. That is the first method to do this. And how about the second method? Since you want to simplify this one, become one of the option, so you can try to substitute some number. For example, substitute x equals 0.5 into question. Okay, so you will have, take out the calculator, 0.5 minus 4 bracket square minus bracket 2 times 0.5 square plus 7 times 0.5, you will get 8.25. So the next step you should do is try to substitute x equals negative 0.5 into option A, B, C, D. Okay, you remember this, when you substitute x equals 0.5, then this one will be 8.25. Alright, so substitute x equals 0.5 in option A, negative 0.5 square minus 7 times 0.5 plus 16. So there's 12.25. Okay, option B, negative 0.5 square minus 15 times 0.5 plus 16, or 8.25. Then you know that B would be the answer because it's matched the number. Okay, so check C and D. 0.5 square plus 7 times 0.5 plus 16, 19.75. Okay, not the answer. And finally D, you will know this is not the answer too, because it's much bigger than 19.7 something, but still try, don't worry. So that's 23.75. So you can see that only B would match with the question, so the answer is B. That's the method, we call it as a method of substitution. That's the very powerful MC technique, okay? Very powerful MC technique you can use. But there's one reminder, do not substitute two simple numbers. Some of you may choose 0, 1, negative 1, 2, negative 2, okay? That's not preferred. because this number are too simple, so the answer of the option may be the same. So that's the end of the MC question, and then let's move to the short question. For question number 1, factorize the following polynomials: A, 3a bracket 4b minus 1 plus 2a bracket 1 minus 4b. Here, what you can do is, you try to think. There's a first term 4b minus 1 and another one 1 minus 4b. You want to swap these two terms. What you can do, you can just change this positive sign to negative. Then there's 4b minus 1. So the only change is all these. Okay? The rest of them, no change. And you can see that now there's a common factor 4b minus 1. You just write down on the left hand side once. Okay, the leftmost position once, and then start a bracket. For the first big expression, after take this one out, you have 3a left. Also, after taking this one out, in the second expression, you have negative 2a left. So, look at the bracket here, 3a minus 2a. Then you will still have 1a. Put it in front of it, okay? So, that's the end of this answer, part A. Some of you may wonder why positive bracket 1 minus 4b equals to negative bracket 4b minus 1. You can do it backward. Try to expand negative 4b minus 1. That's negative 4b plus 1, right? So it can change to 1 minus 4b, right? Just swap these two terms, right? And then you give the bracket to it. So that's a very powerful way if you want to swap the position of these two terms inside the bracket. Just change the sign outside the brackets. So go to part B. There are 6 terms: ax plus 2y minus ay minus 2z minus 2x plus az. You will see that there are 6 terms. Then the only way you can use is grouping, because it seems that no formula you can use. Okay, so try to arrange them in the proper order so that you can take out some common factor. What does that mean by proper order? For example, ax, then that means at least you should have something related to x, right? So we'll try to do something like this. Ax, then we put negative 2x here. Okay? And then how about y? Negative ay plus 2y. And finally, positive az minus 2z. Okay? The first two terms has the common factor x. The next two terms has common factor y. The last two terms has the common factor z. So take it out. X a minus 2. Okay. And here you should pay attention. You can choose take out positive y or negative y. Which one you will choose and why? Try to think. In here we will take out negative y. The reason is, if you take out negative y, then inside the bracket they will left as positive a minus 2. Then you can create a new common factor. If you take out positive y, then inside the bracket that will become negative a plus 2. There's no common factor here. Okay? So for the last two terms, take out z, that's a minus 2. So you can see that there are new common factor a minus 2. You just write it once on the leftmost position, and then inside the bracket For the first term, if you remove this a minus 2, you just have x left. For the second term, if you remove a minus 2, then you just have minus y here. And the third expression, if you remove a minus 2, you just have z here. So the answer is a minus 2 in the first bracket. For the second bracket, that's x minus y plus z. And that's the reminder. Some of you will write down 2 and z in this way. Then you will find it quite easy to mix them together, and then you cannot classify them clearly, especially for some students with the awful handwriting. So that's my suggestion. If you write down the number 2 like this, if you write down the letter Z like this, then you can classify, okay, to prevent the confusion. So let's move to question number 2. If 3 bracket x plus k bracket square minus 1, this one is identical to, okay, mx plus 3 bracket x plus n, these 3 numbers k, m, n are constants. That means x is variable, okay? So then find k, m, and n. And here, what we can do, the usual method is, as the question told you that this is an identity, so you can compare some terms on left-hand side and right-hand side, okay? They must be equal, okay? So you can start with this one, 3 bracket x plus k all square minus 1, 3 horizontal line here, mx plus 3 times x plus n. The next step you will do is, do not handle this 3, just handle the bracket square first, okay? Then x square plus 2kx plus k square minus 1, they will equals to or identical to mx plus 3 times x plus n. Next, multiply 3 here inside the bracket. So every terms inside the bracket should multiply by 3. Okay, so that is 3x squared plus 6kx plus 3k squared minus 1 equals to mx squared plus 3x plus n. And in here you can see that both left hand side and right hand side have the term x squared, x, and constant term. And in here, constant term means there's nothing related to x. So you should add bracket to hold it, okay? This constant term, 3k squared minus 1, will equal to n. So comparing the like term, then we have m equals 3, 6 times k equals 3, that means k equals to 1 over 2. And finally, 3k squared minus 1 equals n, so n equals to 3 times 1 over 2 bracket square minus 1. Then you can use calculator to find this, that's negative 1 over 4. So that's it, the method to find the value of m, k, and n. Okay. Some of you may think, can I use method of substitution in this question? I think it's not quite easy to do so because you will find that there are so many unknown constants here. Then you did not know which number you substitute would cancel some terms to find the desired answer. So in this case, comparing coefficient would be the better way, the robust way to finish it. Okay, and go to question number 3. That is the question about the change subject. Change the subject of each of the following formula to the letter in the square bracket. So that's means in question 3a, you need to make x be subject. Okay, so let's see what we can do. Copy the question first. You will find that mx is the only term containing x. For the term does not contain x, move to another side. So mx equals to c minus my. Finally, divide this variable n to another side. X equal to c minus my, and then a long fraction line divided by m. So finish. Okay. So and then part B, 1 over z equals 1 over x minus 1 over y. That's much more way you need to do, because the terms are in the denominator. Okay. Now some of you make the common mistake. That becomes z equals x minus y. Wrong. Okay. You cannot directly flip the numerator and denominator if there are more than one terms. Okay. You cannot directly flip the numerator and denominator at the same time on the both sides of the equation if there are more than one terms. Okay. So what you need to do is, at least you need to combine this into one fraction. Combine this into one fraction. How? If you really forget how to do this, you can try to substitute some number in rough word. I repeat, you can try to do some experiment in rough word. Okay, do not do it in your exact solution. So, for example, 1 over 3 minus 1 over 5, something like this. Okay, and how could you calculate this without using calculator? You need to multiply these two numbers, or at least finding LCM of these two numbers, right? So the first numerator will be 1 times 5, and then minus here, and for the second numerator we multiply by 3, right? That you can simplify. That's what you can get. We are doing the same thing in this case. 1 over z equals the LCM of x and y, okay, just xy, and the first numerator, just like here, 1 times 5, so 1 times y, minus, for the second denominator, there is 1 times 3 here. Okay, so you are doing the same thing here, 1 times x. So that's the first step you can do to simplify these two fractions into one. Second, now you can see that there are two terms inside the numerator, so give the bracket to it first. As you can see, on both left hand side and right hand side, there are only one fraction now. You can apply cross multiplication. You fix the numerator and then cross multiply the denominator to opposite direction. So xy times 1 equals z times y minus x. So that's the way to remove all fractions. And hence, the remaining step will be quite standard. Do the expansion and move all terms with x on one side. Then take out common factor x that you want. You want x be the subject. Finally, divide this one to another side of the equation. So that's finished. X equals to z times y over y plus z. That's the end of question number 3. I would say for this question, one of the most difficult part is the beginning part. Okay, how to change these two fractions into one. Okay, next go to question number 4. Solve the simultaneous equation 7x plus 8y equals 22. 3x minus 4y equals 2. Now the question didn't tell you which method you will use. That means you can choose either substitution or elimination. Even you can use graphical method if you want, okay, but you need to raise your hand and get the graph paper and then stick on it, okay, is too time consuming, right? So they are expecting you using the algebraic method, okay, algebraic method. That means you should choose either one of these two. So let's investigate which method would be better to use. First of all, we pay attention on the coefficient of the variables. For the variable x, the coefficient is 7, 3. So they are both prime number and not the multiple to each other, of course. So nothing we can observe. So look at the coefficient of y. One of them is 8 and other one is 4. Then we have something to do now. Since one of the coefficient is the multiple of another coefficient, okay, this is a very strong sign to use method of elimination. I repeat, if you find that the coefficient of a variable in one equation is the multiple of that of another equation, then there's a strong hint to use method of elimination. So this is the case now. One of them is 8 and other one is 4. X is the multiple of 4. Okay? And the factor you need to multiply is 2. 2 times 4 will equals 8. After you multiply 2 to this second equation, then you'll find that their coefficient are the same in magnitude. One of them is positive 8 and other one is negative 8. Then you can cancel the variable y. So always choose the good method and then start your work. Do not just write down something without any planning, okay? You need to do some planning before you start your work, okay? So 7x times 8y equals 22. 3x minus 4y equals 2. Equation 1, equation 2. And how to present it more tidily. Some of you may write down, okay, 2 times 2 here, then you write down the equation here, then you cannot match, all right? What I would do is this one. I write down equation 2 times 2. Why I write in this way? Then I will start write down 6x here. 3 times 2, that's 6. Negative 4 times 2, negative 8, equals 2 times 2, 4. And we call it as equation 3. The advantages of for me to doing this, that is, you can directly compare the position, okay, vertically, very clearly. So when you write down some operation, you are advised to write down something in front of this bracket, okay. You should have the hidden line here, okay, for you to leave some space to write down the equation here, okay. Now you can see one of the constant coefficient, that is positive 8 and another one is negative 8. So equation 1 plus equation 3, then you will have 7x plus 6x, directly write down 13x. Positive 8y plus negative y. They're same in magnitude but opposite sign, so it must be cancelled. 0. Just leave it as blank. So 22 plus 4, 26. That's the remaining equation you should handle. So x will be 2. When you get x equals 2, then you can substitute in either equation 1, equation 2 or equation 3, just up to you. So be careful of your calculation. 7 times 2 plus 8 times y equals 22. 8 times y will equals to 8. That's 22 minus 14. So y equals 1. Then you always have this one. 5 star here. Therefore, x equals 2 and y equals 1. You always have this one, okay, always. So that's the end of question number 4. On the level of difficulty is not so much, but the key point is you should choose the proper method. If you insist using method of substitution, you will get some trouble because you will observe that there are lots of fractions when you're solving the equation, okay? I will not say you can't do it, but it will bring you a lot of trouble, okay? So go to question number 5. There's a word problem, and a box of candy is shared among all students in class. Each student gets 4 candies, then 30 candies are left. If 4 of the students does not get any candies, each of the remaining students gets 6 candies, okay? Now the tricky point is there are 2 variables, okay? The first variable is the number of students in class, okay? Another variable is number of candies, okay? So what we can do is, okay, let x be the number of candies, okay, and let n be the number of students, okay. Then you have 2 equations here, sorry, 2 unknowns here, then you need 2 equations. First equation, look at the first statement. X is shared to all students, okay? If each of the students get 4 candies, then 30 candies are left. That means 1 student gets 4 candies, n student gets 4n candies, okay? You have 30 candies left. So the total number of candy, x, will be 4n plus 30. That's equation 1. Okay, the second statement. 4 of the students have no any candy. Look at this one. Remaining student. How many students left? That is n minus 4. Because 4 of them do not have any candies. So remaining student will get 6 candies. Therefore, 6 times n minus 4. That equals x. If 4 students did not get any candies, then the remaining n minus 4 students, each of them will get 6 candies, completely given out. So that's equation 2. And the key symbol is this big bracket. That means you need to satisfy these both conditions or both equations. You can see that there are x in the subject, so 4n plus 30 equal to 6 bracket n minus 4. And then you can solve n directly. They are quite straightforward. N is 27. There are 27 students in the class, and x would be equals to 4 times 27 plus 30, that is 138. Now you solve the variable n equals 27, x equals 138. But you need the final statement because you are working with the word problem. There are 27 students and 138 candies, okay, at the final statement. So that's the end of question number 5. And go to question number 6. Find the unknown in the following figure. But that's a very standard question of the application of the Pythagoras Theorem. In the right angle triangle, if you want to find the length of the side of the triangle, Pythagoras Theorem is a very powerful tool to use, okay? You will see it very often. And the key point is you need to know which side is the longest, okay? Which side is the longest side? Usually, the side opposite to the right angle is the longest, okay? And we call this line is hypotenuse. It's only used in the right angle triangle, or mainly used in the right angle triangle, okay? So, applying Pythagoras theorem, x squared plus 6 squared, the sum of square of two shorter side will equal to the sum to the square of the longest side. Okay, reason Pythagoras theorem. So x squared would equal to 8.7 squared minus 6 squared, right? Then use a calculator to help you. 8.7 squared minus 6 squared. So x squared, that is 39.69. So you take the square root. That's 6.3. X equal to 6.3 or x equals to negative 6.3. You always have two solutions when you are working with the equation with power 2. Two answers, one positive, one negative. But of course, in this case, x is talking about the length of the triangle, so the negative answer should be rejected. You must have this one, okay? That's your criteria to use Pythagoras theorem. But of course, in the higher form, even though you are in form 4 or above, they just ask you to find x. Then you can write in this way, in form 4 or above. Okay, form 4 or above, okay? X equal to square root 8.7 square minus 6 square, then there is 6.3. Because we understood the length must be positive, so you can use one line to write this. But we are going to train you the format of the Pythagoras theorem. So in form 2, you must write down something like this, okay? Form 4 or above, you can write down something like this. And how about form 3? We should depend on your learning progress in form 2. If your work is really bad, then in form 3, we may still need you to present something like this, okay? It's usually under the discussion. So that's the end of question number 6. And go to question number 7. Determine if triangle ABC is a right angled triangle. Again, take the longest side first, that's 50. So we check 50 alone. AC squared, that is 50 squared, equals to 2,500. And for two shorter sides, you need to check the sum of square. You must call AB squared plus BC squared. You must call the name of the length. You must call the name of the side, okay? 30 squared plus 40 squared, that is 900 plus 1,600, that's 2,500. So you can see that when you check them separately, the square of the longest side equals to the sum of square of two shorter sides. Then you can present like this, because the sum of square of two shorter sides equals to the square of the longest side. This is not using Pythagoras theorem. This is not using the Pythagoras theorem. This is not using the Pythagoras theorem. This is just checked by the numbers only, okay? But you luckily find them. This equation holds. Therefore, angle ABC equals 90 degrees. Because you have this equation, okay, then you can make the conclusion that this is right angle. Here you are applying converse of Pythagoras theorem. Okay, the reason right here. And therefore, triangle ABC is a right angled triangle. Remember, you should state this one first. Some of you omit this one. Just because AB squared plus BC squared equals AC squared, therefore this is a right angle triangle. Not okay. Not okay. Because you need to state clearly which angle is a right angle. Then you make the conclusion this is a right angle triangle. Okay? And here some common mistake. 50 squared equals 30 squared plus 40 squared. Okay? Some of you directly write down something like this. It is not the proof. You are just telling the number relationship. Okay? You are not referring the length of the triangle. So when you present in this way, no mark. Okay? I will ask you, why don't you write down 2 equals 1 plus 1? It's also true, right? You are just telling me the relationship among the number, right? So do not just directly quote the number. You need to also refer the name of the length. Okay? Also, some of you may try to write in this way. They check this all correct. Then they say, okay, then AB squared plus BC squared equals AC squared. Pythagoras Theorem. Wrong. 0 mark if you write in this way. Because up to this step, you still don't know whether it is a right angle triangle or not. But you luckily find that the number satisfies this equation. Okay? So you cannot just say, okay, this comes from Pythagoras theorem. This is not come from Pythagoras theorem. So when you write in this way, must be 0 mark. So that's the end of question number 7. And then go to question number 8. You need to simplify this and keyword rationalize. That means I don't want the square root in the denominator. I don't want any square root in the denominator. Okay? So that's a very key concept. For example, if you find there's a square root in the denominator, then you need to multiply both numerator and denominator by a square root a again. Then it makes to a in the denominator and square root a in the numerator. That's the method we call as rationalize. Okay? So let's look at the solution. Square root 6 times square root 5 divided by square root 35. So when you are multiplying these two, then it can be written as square root 30. Because square root a times square root b equal to square root a times b. But of course, AB should be positive. Okay? AB should be positive here, or at least 0. Okay? And square root 30 over square root 35, it can be written as 1 square root 30 over 35. Again, when you are doing division, a square root a divided by square root b, you can change it to become a big square root sign. Again, a and b should be non-negative. Okay? A, b are non-negative number. So go to here, you can cancel the common factors. 5. So square root 6, square root 7. And you find that there's a denominator, square root 7. So you need to do is multiply both numerator, square root 7, and denominator, square root 7. And hence, in the denominator, square root 7 times square root 7, just go back to 7. In the numerator, square root 6 times square root 7, that's square root 42. So that is your final answer. Okay, so that's the end of question number 8. And then let's go to question number 9. Find the unknown in each of the following figures. You will see that there are some angles in the right angle triangle, and if you can observe this, there's some special angles 45 degree here, okay. So what we can do, if we want to find x, when you look at this angle 45 degree, okay, 45 degree compared to x, that is the adjacent angle, okay, adjacent angle, and the side opposite to the right angle is the hypotenuse. So adjacent side over hypotenuse will equals to cosine 45 degree. And how do you memorize that is cosine? Okay, if the angles are given, you can write down C here. You can write down the C here, okay? That means cosine must be related to these two lines. Must be related to these two lines. One of them will be in numerator, upper part, okay, of the fraction, and another one must be in the denominator, okay, the lower part of the lower part of the fraction. And the hypotenuse, that means the side opposite to the right angle must be in the denominator. So you fix this one first, and then x will be the numerator. Hence, how do we write down cosine 45? If you use calculator, then you will luckily find that there's 0.707 something. Then some of you may think, okay, then I multiply 2 times root 2. Luckily, you get 2. Okay, so x is equal to 2. But there's a little bit thing I would like to discuss to all of you. When you press cosine 45 degree, there's a long decimals. But actually, it can be a surd form. It's a surd of the some number, the square root of some number. How to get cosine 45 in surd form? You can draw something in your rough work. Okay? Suppose you have the right angle triangle. These two angles are both 45 degrees. Then I assume these two lengths be 1. By using Pythagoras Theorem, you can find the hypotenuse will be square root 2. So cosine 45 degree, that is 1 over square root 2. That's the way you can find cosine 45 in surd form. Here you can write in this way, cosine 45, that's 1 over root 2, and then multiply this one to another side, x equals 2. Then you will know that x is exactly equal to 2. Okay? If you use calculator, you may say x can be round off to be 2. If you use calculator, you can just say x can be round off to be 2. But you cannot tell x is exactly equals to 2. That's the difference. So you need to express cosine 45 degree in surd form. Alright? So for question 9b, you need to find this angle theta. So if you find that when you draw a C here, then there's a cosine related to this number 5 and this hypotenuse. Okay, then you do not have this length. Of course, you can use Pythagoras Theorem to find this hypotenuse, but it seems clumsy. How about whether we can use these two? You can try to do something like this. For this theta, you draw the line like this. Then this line 5 over square root 3 will be the opposite side of this theta. Okay? And you draw a t here, small letter t here. That means if you want to apply tangent, then it must be something related to these two lines. So tangent theta must be related to these two lines. But which line in the numerator? Okay, again, the opposite side would be in the numerator. Denominator 5. Okay? So if you're using cosine, hypotenuse will always in the denominator. Also sine, if you are using sine, hypotenuse always in the denominator. But when you are using tangent, then the adjacent side will be in the denominator. Okay? So simplify this one. Tangent theta would equal to 5 over square root 3. This number 5 can be written as 5 over 1. If you want to swap this one, if you want to change this division becomes multiplication, then that's the way you should do. Multiply 1 over 5. Just swap the fraction in the denominator, okay? So cancel these two numbers. Tangent theta equals 1 over square root 3. And how do we get theta? Okay, first of all, press 1 over square root 3. You get 0.57 something, and then shift tangent. Answer. EXE. Theta is 30 degrees. Now pay attention to the present. Tangent theta is the trigonometric ratio, or a fraction here in this case. After you press shift tangent, you are finding theta. It is degree. Two things, okay? You always write down left hand side and right hand side in your present. You should always write down left hand side and right hand side in your present. If tangent theta equals a number 1 over square root 3, then angle, this one, theta, will be 30 degrees. If you omit this one, not correct, okay? So that's the end of question number 9. And go to question number 10. You need to prove this. Proof. That means you cannot start with this one directly. You need to split it into left hand side and right hand side. Do it separately. When you need to prove some identities, then use the blue pen to draw this line. To remind yourself, you should do them separately. Okay? Do them separately. Left hand side, 1 plus cosine theta, 1 minus cosine theta times 1 plus cosine theta. As you can see, this one is quite standard for the A minus B times A plus B, right? So you can apply the difference of two square formula, that is A square minus B square. And you know 1 square equals to 1. And cosine theta bracket square, we can written as cosine square theta, like this. So how do we simplify this? 1 minus cosine square theta actually is sine square theta. Okay? Some of you may not know why. Let me explain to you. As you learn the formula, cosine square theta plus sine square theta equals 1, right? Then you just move this positive cosine square theta to another side. You can write down sine square theta equals 1 minus cosine square theta. Okay? That's the way we can simplify something like this. So, left hand side, you cannot simplify it more, then go to right hand side. Tangent square theta times cosine square theta. As you can see, there's something like A square times B square, right? So you can just take out the common index 2, becomes A times B all square. That's the way I would do. Tangent theta times cosine theta all square. And then, how about tangent theta can be simplified? Tangent theta can be simplified as sine theta over cosine theta. So you can change this one into sine theta over cosine theta. and then times another cosine theta. You should have a bracket square here. You can cancel the common factor, not common factor, you can cancel the factor cosine theta, then you left sine theta bracket square, and of course this is sine square theta. Okay, so left hand side you simplified it, right hand side you simplified it. Luckily they are the same, because left hand side equals to right hand side, therefore this is an identity. You can just write down one statement or just directly copy the question. Okay, that's it. I repeat, when you are asked to prove the identity, one of the common way is, okay, you just directly split the solution into two parts. You simplify left hand side and simplify right hand side separately. Okay, draw this line. Okay, so that's the end of question number 10, and go to question number 11. In the figure, A, B, C, D, E, F, G, H, they are both rectangles, and similar figure, that's the key word, similar. When you see the word similar, that means the corresponding length ratio are equal. That's the key concept of similar figures. So the length that is 32 and corresponding length of the smaller triangle, also the smaller rectangle, is x plus 9, and the corresponding the breadth of the big rectangle is 20, and the corresponding breadth of the small triangle is x. Then you have the equation here, 32 x plus 9 here, okay, 20 x here. Solve the equation. 32 times x equals 20 times x plus 9, and then simplify it. So 12x equals 1x0, x equals 15. That's it. That's the solution of question number 11. This question just asks you whether you know the meaning of the word similar. Okay, question number 12, that's the question about ratio. Sam and Carol are two salesmen in a car dealership. Last month, the ratio of the number of cars sold by Sam to the number of cars sold by Carol is 3 to 8. If Sam and Carol sold 44 cars in total last month, how many cars does they sell? Okay. If the ratios are given, then you can use K method. Suppose Sam was sold 3K. Should match is okay. Be careful. Sam sold 3K car. Carol sold 8K car. Sam sold 3K cars. Okay. We know that's last month, so okay. So no need to write down last month. Okay. So 3K, that's the number of cars that Sam sold, plus 8K, that's the number of cars Carol sold, equals to 44. Then K is 11. Therefore, Sam sold 3 times 11, that's 33 cars. Okay, that's a very common method to solve such kind of the word problem related to ratio. If the ratio are given, K method is one of the good way to do it. Okay. Then what does that mean by K method? Some of you may forget. Let me explain. Okay, Sam, Carol. Sam sold, what, we don't know how many cars at the beginning, right? But we just know the ratio. Sam to Carol, 3 to 8. Okay, let's simply say. Okay, not grammatically correct, but okay, I'll just say it. 3 part. Carol, 8 part. Okay, just draw 3 circle and 8 circle, something like this. we suppose one circle represent 1K, then Sam will have solved 3K card. How about Carol? Then corresponding part is 8, right? So 8K. That's K method comes from, okay? Of course, you can use X, you can use Y, just up to you, okay? But usually we use K only. So that's why we call K method. You can use other unknown if you want. So that's the end of question number 12. And go to question number 13. And simplify these expressions and give your answer in short form if necessary. So cosine 30, okay, how would you get this value? You can draw something in your rough work. Draw the right angle triangle, 30 degree, 60 degree, okay? The 30 degree point to the left, and you can write down some numbers from the vertical one in anti-clockwise direction. 1, 2, -3. Okay? Then you can see cosine would be square root 3 over 2. Cosine would be square root 3 over 2. And how about sine 60? Again, when you look at this number 60, the side opposite to 60 is this one. Opposite side over hypotenuse, again, square root 3 over 2. Alright? Some of you think, oh, I don't know how to get this. I really forgot how to draw this triangle. Then what we can do, one more method. You use calculator, okay? Cosine 30, you get this one, very accurate, right? So that's the hints. Cosine 30 degree, that is about 0.8660 something. But when you press square, then you get 0.75. That means cosine 30 degree, when you take square, you will get 0.75. When you press this fraction button, that is 3 over 4. Okay? So how to get back cosine 30 degree? You just take square root. So square root 3, of course it's square root 3, you cannot simplify. How about square root 4? That's 2. That's the way for you to using calculator to get back the short form of the cosine 30 degree. Okay? It's also work in other special angle. For example, tangent 60 degree, that's this number. How about take square? That's 3. That means tangent 60 degree bracket square is 3. So tangent 60 degree will be square root 3, right? So you can use this method to help you. But go back to this question now. Cosine 30 degree times sine square 90 degree minus theta plus sine 60 degree times sine square theta. Then what you get is square root 3 over 2 multiply. This one, sine 90 degree minus theta, that's changed to cosine theta. The square, keep it, okay? Plus sine 60 degree, as I explained, is also equal to square root 3 over 2. So you can take out the common factor, square root 3 over 2. That is cosine square theta plus sine square theta. And you can use the formula, cosine square theta plus sine square theta, that's 1. So final answer, square root 3 over 2. Okay? And for question number 14, find A in this figure. You will see that there are so many angles outside the figure. So let me tell you what is this. We call all this as exterior angle. How to define it? First of all, you will have some figure with the polygon. Okay, the angle formed by the adjacent side of the polygon, this one, for example, M and P, something like this. All this we call it as interior angle. And how to define exterior angle? You extend one line, only one line. Then this red line and the blue line here, we call it as exterior angle. Okay, you can extend in this direction also. It's also called exterior angles. Okay, but in this case, if you extend both, this one is not an exterior angle. The key point is you just need to extend one line. Okay, so you need to check. Okay, for all these angles, okay, they just extend one line, so they are all exterior angles. And in any polygon, the sum of all exterior angles must be 360. So you can set up the very simple equation. You just add all these angles up. Equal to 360 degrees. And reason, you write it here. Sum of exterior angles of polygon. Alright, so 2a plus 256 degrees equals 360 degrees. You just add all these angles up. 2a equals to 104 degrees and a is 52 degrees. That's it. Okay. So go to question number 15. Okay, the following figure shows a regular decagon, and you can see what is the meaning of decagon. DEC is quite similar to December, right? So you may think 12, but no, you need to minus it by 2. It's 10 side polygon. You can see more examples. For example, November nonagon. Then you may think of November, right? 11, but you minus it by 2. That's 9 side polygon. How about octagon? OCT start with, right? So October, you may think of 10, but 10 minus 2, that is 8 side polygon. So here there's a 10 side polygon. In exam, they may not give you the figure, so you should know the meaning of this word. It's 10 side polygon. You need to find the size of HGF. So HGF quite straightforward. That is 10 minus 2 times 180 degrees. That is the sum of all interior angles in 10 side polygon, right? But there's another keyword, regular. That means all sides equal and all angles equal. So you just need to find the sum of all these 10 angles divided by 10. So you can 144 degrees. Next, you need to find angle HFG. HFG. Then you need to add the straight line by yourself. That is 144, right? These two lines are the same. So this is an isosceles triangle. And these two angles are the same. Theta will be 180 degrees minus the top angle and then divided by 2. So that is 18 degrees. Finally, you need to find angle HFD. Then you need to add this line. Find this one. Now you know that this theta is 18. Then how about this angle? Try to observe triangle HFG and F dot E. actually they are congruent. Triangle HFG actually is congruent to triangle F dot E SAS. If you want to prove it, okay, you're welcome. This theta also. So, how to find the middle angle? Phi plus 2 theta would be 144 degree. And you can find this one, phi, that is 108 degree. So angle HF dot 108 degree. Okay? So question number 16. In this figure, these two lines are parallel. Find x, then quite straightforward. You can look at this one, PQRS. Just look at this one. This is 137 degree. And this one, x plus 5, x minus 1 degree, so 6x minus 1 degree. So you can set up the equation directly. 6x minus 1 degree equals to 137 degree. Reason, alternate angles, PQ parallel to RS. Then you can solve x, that is 23 degree. And B, you need to show that these two lines are not parallel. Okay? So find angle RTU, that is 3 times 23 degree, that is 69 degree. That's 69 degree. And angle TRS, that is 5 times 23 degree minus 1. 104 degree. When you add them together, angle RTU plus angle TRS would equal to 69 degree plus 114 degree. That is 183 degree. That's the key point you need to write down. You must write down this one, not equal to 180 degree. You must have this one. Okay? Because you need to check if these angles, add them together, equals to 180 degree, then these two lines will be parallel. Otherwise, they are not parallel. So you must make the comparison. So make the conclusion, therefore, RS is not parallel to TU. Okay, that's the end of question number 16. And for question number 17, in the figure, BCD is a straight line, AC equals to CD, BA is perpendicular to AD, so mark the right angle here. If angle ADC equals Y, prove that ABC, this one is an isosceles triangle. So the condition of proving they are isosceles triangle, then at least two angles equal, right? If you want to prove that there are at least two angles equal, then, or you may prove at least two lines equal, right? Or two sides. So we have this unknown angle Y. We try to find all these angles in terms of Y. That's a key concept. Do not add something more X, Z. No, we try to use this Y as much as possible. It is Y. This is also Y. This will be 90 degree minus Y. On the other hand, when you add these two up, this will be 2Y. So finally, this angle B will be 1x0 degree minus its top angle, 90 degree minus Y, and then minus 2Y. Then you will find that is 90 degree minus y again. So that means AC and BC are equal. That's the process of finding all angles in this figure. Okay, try to use as many formula or as many relationships as you know to find all angles in terms of y. But the problem is, even you know, okay, they are the same. So what? How to present it? Okay, the question told you that this angle ABC is y already. So the first step you'll find is this one, right? Write down 1 here. The second step you'll find this angle. And the first step you find this angle, right? Y plus y equals to y. And this is the fourth step. Just follow the order of the number to present it one by one. Don't worry. 1. Angle CAD also equals y. Reason: base angles, isosceles triangle. Okay? Or I should write down something in another paper so that you can check, you can compare the number. Okay? Let me look at the way to present it more clearly. Okay, I write it in here. Step 1. Angle CAD also equals y. And the reason, base angles, isosceles triangle. Okay? And second, you find this one. Angle BAC will equals to 90 degree minus angle CAD, right? So angle BAC will equals to 90 degree minus y. That's the second steps. And the first step, you'll find this one. Angle ACB equals to y plus y. Reason: exterior angle of triangle. Then you find angle ACB, that is 2y. Next, you need to find this angle ABC. Angle ABC plus 90 degree minus y plus 2y equals 180 degree. Reason: angle sum of triangle. Okay? Then you can find angle ABC will equals to plus 90 degree minus y plus 2y. That's 90 degree plus y equal 180 degree. So angle ABC will be equal to 90 degree minus y. Again. So you can see that BAC is 90 degree minus y. ABC also 90 degree minus y. You can say because angle ABC equals angle BAC equals 90 degree minus y. So go back to the graph. When these two angles are the same, that means these two lengths are equal. Therefore, AC equals BC. Side opposite equal angle. And therefore, you can conclude that triangle ABC is an isosceles triangle. So that's the whole proof. Okay, and I decrease the size of the camera so you can see the whole proof. That's the whole process of proof. Okay, there's 1, there's 2, there's 3, there's 4. Okay, finally you need to state, okay, these two angles are equal, so this is an isosceles triangle. That's the whole proof. And that's the end of this